Description of the problem. Problem number 9 is an easy question. Okay, I'm gonna have to revisit this. It's been a while. Are you guys able to see my screen? The LeetCode window where it says palindrome number.
Yes, sir. Screen is visible.
Okay. Just give me 1 second. I need to clear something up. Okay, let's go to the question. Where's the question now? Palindrome number. I'll turn on the annotator and let me magnify this a little bit. Okay. Code. I'm going to code this in Java. You're given an integer x. Return true if x is a palindrome and false otherwise. Okay. The question is giving you some input that is an integer. First, we have to determine the input and the input data type. It's an integer. So x is equal to 121 is an example where x is the integer and 121 is a number. So what they're saying is return true if x is a palindrome. What is a palindrome? You can take a peek at the definition of palindrome here. An integer is a palindrome when it reads the same forward and backward. Okay. So if you're given an integer, if you reverse that integer, if you change the sequence where your last one goes to first, second one to the second last, and then this first one goes to last, you still get 121. If I were to move this one here, 1, and then 1 here, and then 2, hold on, I'm reversing it, I'm not doing it right. If I reverse this number, if I flip it around, I still get 121 by moving this one here, and then 2 after that, and then 1. This one goes here. I still get 121, right? So that kind of number would be a palindrome, okay? Is this a palindrome? No, it is not. Why? Because if you flip it around, you have 121 minus, right? Which I doubt it itself is even an integer. This will return you an error. And then you have 10, where if you flip it around, you have 0, 1, which is again not a palindrome. So you need to find out if your number is a palindrome. A very easy approach to solve this problem would be to store this number, convert this number into a string. Okay. Store this number into a string. And so that becomes 121, and then just reverse the string. In that case, if the initial string is equal to the reverse string, then you have a palindrome. Does that make sense? If I convert the data type of this, if I make 121 string instead of the integer, because I cannot flip integer around, probably I may be able to do it through some bitwise operations, but that's, I think it's going to take a lot of thought. But in string, I can just flip around based upon indices, right? I can swap the elements, or I can use an inbuilt function that reverses the string, and then I can store it inside another variable where it will be again 121. And if this string is equal to this string right here, then that means I have palindrome. So in Java, how it would look like, let's do its code implementation. Since it's an easy problem, we shouldn't spend too much time into like nitty-gritty details. Okay, so let me define, okay. First, let's convert this integer to string. That should be our first step. String original equals integer. Yes, Asad, go ahead. That's your question. And I'll define another one as an empty string. Asad, you wanted to say something? Okay. Um, I define another variable named as reverse string. And now what I need to do is flip this around. Okay. And then store it inside reverse. Okay.
Oh,
Yeah.
am I audible?
Yes, you are now.
I want to say, shouldn't we first just obsolete all the negative numbers? Like, we should only consider the positive number. If there is a negative sign, it won't be a palindrome. So, shouldn't we just convert them into a positive integer first, or obsolete the negative number? If a number is less than zero, we should uh return false.
Yeah, you're right. We can write an edge case if a number is negative. We just return false altogether because in any case you have a negative number is going to be, the negative sign will fall on the other side, which is not, you know, a proper number at all. First of all, it's not even an integer. I don't know what kind of rules apply in
I
coding
guess
languages, but
I want to point something out. It is an integer, but a negative integer.
how come the sign is on the other side? In coding, does that count as a negative number? 121 minus. That is like an operation. You're operating it with what?
Yeah, this is not an integer, but if a negative 121, that's an integer.
Yeah, no, I'm talking about when you flip it around, then you don't even have a proper integer, proper value, right?
Yeah.
So in that case, you can just disregard all the negatives. And we may have a function for that. We'll think about it later. Let's figure this one out first. Okay. So how do I reverse this string? Now that I have converted it to string, integer dot to string, how do I reverse that? If I run a loop in the opposite direction of the string and start storing each element to a new string, by which I mean is if you have a number 1, 2, 1, 3, 4, okay, and the variable is assigned to is x is equal to 1, 2, 1, 3, 4, and then I introduce a new string, and if I start picking each and every element one by one and start putting it one after another, will I have a reverse string? Yes or no?
Yes, but we have another optimized solution, that is by swapping using two pointers.
Yeah, we can swap too. That's correct.
Yes.
For swapping, I guess you're gonna have to use a
Uh,
something like a temporary variable where you assign.
no, yes, two pointers needed.
just 2 pointers.
Yes.
Okay, let's go brute force, and then I'll let you help me implement the what's it called, 2-pointer swap, because right now I'm out of my thinking capacity. I've been working this problem for like 8 hours. So anyways, so now let's implement the inverse for loop, and then we'll go your optimized way to do that. Okay. And then we'll also implement the edge case from Asad. So let's implement the loop. I'll use the usual if integer, initializing integer I is equal to 0. No. What we want to do is we want to go reverse, right? If you want to go reverse in a string, we have to start at the last index. So if this right here, if this right here is my string, this is 0, 1, 2. But if we go in reverse direction, we have -1, -2, -3. But if I want to start at the end of the array, I need to first find the index. The index would be length of the string minus 1, right? This will give me the last index. Then I'll start from this and I'll decrement, which means if my iterator I is here, it will go by I minus 1, until it reaches the 0th index. So as long as my I is greater than or equal to 0, I can execute my logic under the loop, else I'll break out of the loop. Okay, let's implement this in practice. So I'll initialize integer I, which is my iterator, to the length of the array, length of the string. So the original string name is original, right? And if I do length function -1, and I have to make sure that my I is greater than 0 because I'm moving in the opposite direction, or greater than or equal to 0. I want to include 0 as well. And then I decrement I minus minus, which also means I minus 1. Okay, but this is a standard practice. Okay, now that I'm iterating in the reverse direction, now I need to get each and every element of this, each and every character of the string, right? We don't call them elements, we call them characters. Okay, remember I told you a character is between single commas and string is between double commas. Okay.
Well,
So now let's go ahead and start adding reversed plus equal to. We are adding to reverse string, and we are also storing it in the reverse string. What are we doing? In Java, we use original, the name of the string, and then character at what? The iterator, which is I. So I put my I here and close this statement. Okay. And then finally, what do I need to return? Okay. We can check if reversed, if the reverse string is equal to the original string, will return true. Else will return false. Let's see if this works. Okay, what went wrong here? For 121, I reverse the string, and I'm returning false. let's see, reverse dot equals, does this have something to do with this one right here? Okay. This has to do something with the function because strings don't just get these two equal signs. First to set them equal and then to compare if they are actually equal. So we use this function right here. I don't know what is the idea behind this equals. We can explore that later, but this has to be logic there where we're computing the, yes, that's what we use for comparison. So if we submit this solution, this is going to be OFN solution because we're iterating over the entire string, the length of the string, which is the number. But now let's optimize this further. Do you want to code or do you want to tell me and I'll implement it? Sorry, who gave me this? It's just the optimal solution.
I think we can't use two pointers swapping here because that modifies the original string. So in that case, we can't do comparison here. That's why we can't use that solution.
I think we can use two pointer by converting this integer into string, and we don't need to swap the elements. We just compare left and right. If both are equal, that's fine. At any stage, both of them are not equal, we can return true as well.
So you're saying basically if we have 1, 2, 2, 1, if we flip them around, 1, 2, 2, 1, and you're trying to start from here and here, and as long as you find equal until here, then you're fine. You want to
Yes.
divide the length? You want to split the string in a half? Or what you can do is, what if you have a case where 1, 2,
Sir, I have one more solution. I studied this problem before and I had just a more better solution.
okay, we'll go to your solution. What we'll do in this case if we are implementing this left and right pointer? Who was
Sir, let me explain.
Mhm.
Can you please allow to annotate me?
How do we do that? Let's see. Who can see what you share here? The upper toolbar. I think you'll have to request it, and then I'll have to give you the permissions to.
Okay.
Can you see if you can request it? Because I don't
Uh,
have the. Hold on, I think there are enable invitation for others. Okay, go
can
ahead.
can I share my screen?
Actually, you can go ahead and use annotator.
जी
Yeah.
मैं कुछ ऐड करना चाहूँगा। अच्छा, मैंने ये नोट किया है जिसमें ये बताया गया है कि एग्जाम्पल नंबर 1, एग्जाम्पल नंबर 2 और एग्जाम्पल नंबर 3 में नोट करें कि इनपुट में हमें दिया हुआ है कि 1 to 1, ठीक है। और ये ट्रू हुआ इस तरह है कि आपको एक्सप्रेशन में बिल्कुल बकायदा बताया कि 1 to 1 रीड हैज 1 to 1 फ्रॉम लेफ्ट टू राइट, मीन्स कि लेफ्ट और राइट में जो फॉर्म दिया हुआ है वो बिल्कुल सही होना चाहिए, ठीक है। ये इजी वर्ड में है, अगर आपका ये सही है तो आपका ट्रू होगा। सही है, अगर आपने 1 to 1 देखा कि आपने 1 to 1 जो है वो सही पे चल रहा है तो आपका ये ट्रू कहलाएगा, ठीक है। अब एग्जाम्पल नंबर 2 में देखें कि एग्जाम्पल नंबर 2 में क्या होता है कि x इज इक्वल टू -1 to 1, सही, तो ये फॉल्स कहलाएगा। क्यों? क्योंकि देखिए -1 आ रहा है। सही है, अगर हम इसको लेफ्ट टू राइट देखेंगे तो ये -1 और लेफ्ट पर जाएगा, राइट पर तो ये 1 माइनस हो जाएगा। ये देखने नीचे लिखा हुआ है कि फ्रॉम लेफ्ट टू राइट बिकॉज द 1 -1 to 1 फ्रॉम टू राइट टू लेफ्ट बिकम टू 1 to -1 1 माइनस, तो ये रॉन्ग होगा। तो हमें सेम लेकर आना है कि इस हिसाब से हमारा वो लेकर चलेगी। किस तरह से लेकर आना है? जिस तरह ये आपको बताया गया है ऊपर, तो ये -1 से ही लेकर आना है, ठीक है। अगर ये देखे ऊपर देखे कि सेम आ रहा है और उसने जब उसको पलट रहा है तो वो सेम ही आ रहा है तो इसलिए वो ट्रू कहलाती है। अगर आप एग्जाम्पल नंबर 3 में देखें कि एग्जाम्पल नंबर 3 में बिल्कुल सिंपल से बताया गया है कि 10 है। फॉल्स क्यों आया? कि उसने जब उसको लेफ्ट टू राइट किया तो देखिए 0 1 आ रहा है। राइट और लेफ्ट को देखें कि राइट पे कोई 0 आ रहा है और वो लेफ्ट पे भी 1 आ रहा है। अगर हमें लेकर के आना है, हमें इक्वल लेकर आना है कि जो राइट पे भी हो लेफ्ट पे भी हो। तो हमारा जो पहला जो आंसर है वो ट्रू इसलिए क्योंकि देखिए 1 राइट पे भी गया और लेफ्ट पे भी गया तो सेम ही आया। ठीक है, हमने सेकंड एग्जाम्पल में भी अगर हमने लेफ्ट राइट को राइट वाला 1 है और लेफ्ट वाला 1 है, उसको अगर हम उसको चेंज करते हैं तो -1 1 माइनस आएगा। और अगर हम एग्जाम्पल नंबर 3 में देखते हैं कि 10 है, अगर हम उसको लेफ्ट में करें और राइट में करें तो 0 1 आएगा। तो इसीलिए नीचे एग्जाम्पल नंबर 3 एग्जाम्पल नंबर 2 फॉल्स करा गई है और एग्जाम्पल नंबर 1 वो ट्रू कराई गई है। जी सर।
जी सर, आप ये कहना चाह रहे हैं कि एग्जाम्पल्स को कंसिडर करना चाहिए प्रॉपरली
जी सर,
बिफोर।
क्योंकि देखें एग्जाम्पल्स को देखकर ही क्वेश्चंस किए जाते हैं। अभी देखिए एग्जाम्पल में जो बताया गया है तो उस हिसाब से ही क्वेश्चन किए जाएंगे। देखिए अब एग्जाम्पल नंबर 1 में बताया गया है कि इनपुट क्या दिया गया, आउटपुट क्या दिया, उस हिसाब से एक्सप्लेनेशन में किया जाएगा कि भाई ये एक्सप्रेशन है, उसको ये आउटपुट होना चाहिए, ये चीज़ है। अगर हम उस एग्जाम्पल के हिसाब से नहीं लेके चलेंगे और अपना कोड लिखेंगे तो एग्जैक्टली एरर देगा, क्योंकि कोड हम लीड कोड हमेशा वही रिकमेंड करता है जो एग्जाम्पल्स दिया होता है।
हम्म, राइट। ये सजेशन आपने किसी क्वेश्चन के आंसर में
नहीं
दिया है
नहीं,
या जनरली?
ये सजेशन ये पहले से ही है। ये
ओके,
जिससे स्टूडेंट से जब से लीड कोड स्टार्ट हो रहा है, ये
कूल,
सजेशन सबसे ये कि एग्जाम्पल को देखकर ही उसको लेकर
राइट।
चलना है। क्योंकि अगर एग्जाम्पल को देख के नहीं लेके चलेंगे आप लोग, ऐसे आपने देखा कि हाँ ये क्वेश्चन है पैरामीटर नंबर और अपने अपने मार्क्स से कोड लिख दिया पाइथन का C++ का, तो वो तो एक्सेप्ट तो वो उस वक्त करेगा ना जो एग्जाम्पल से मैच किया जाएगा। अगर आप एग्जाम्पल से मैच करके आप कोड करेंगे तो एग्जैक्टली एक्सेप्ट होगा। अगर आप एग्जाम्पल से हटकर आप करेंगे तो एग्जैक्टली रॉन्ग क्वेश्चन देगा, लिमिटेड क्वेश्चन बार बार आप करते रहेंगे वो रॉन्ग ही देगा। जी सर।
सॉरी, मैं यहाँ पे आपकी बात इंटरप्ट कर रहा हूँ। एक खाली एग्जांपल्स को हम नहीं देख सकते, क्योंकि जब हम सबमिट कराते हैं तो ये मल्टीपल टेस्ट केसेस को टेस्ट करता है। तो कभी
जी
कभी ऐसा
सर।
भी होता है कि खाली आपके टेस्ट केसेस जो नीचे एग्जांपल होते हैं वो तो कवर हो जाते हैं, लेकिन जब आप एक्सेप्शनल उस पर जाते हैं और सबमिट करवाते हैं तो फिर वो वहाँ पे उसको रिफ्यूज कर देता है, उसमें एरर आ जाता है। रिसेंटली मैंने ये चीज़ फेस की है, मैं आपको इसीलिए बता रहा हूँ।
सर देखें कि एक एग्जांपल मैं बताता हूँ आपको, जैसे कि अगर आप एग्जांपल्स के हिसाब से लेके चलते हैं, ठीक है, और अगर आप उस पे लेके चलते हैं तो वो आपको फॉल्स तो एक्सेप्ट तो कर देता है एग्जाम्पल के सब पे। और फिर जब वो एक्सेप्ट सबमिट जब आप करवाते हैं तो उसकी रिफ्रेशिंग चेंज हो जाती है। क्यों? क्योंकि वो चेक करता है कि हमारी जो पावर पॉइंट्स जो उसकी जो एक्सेप्ट पॉइंट्स हैं, इसकी स्पेस कॉम्प्लेक्सिटी और टाइम कॉम्प्लेक्सिटी, उसको चेक करता है कि उसकी क्या बन रही है। वो हिसाब से उसको चेंज करके बताते हैं। अगर वो सेम करके बताती तो हमेशा रॉन्ग ही आएगा अक्सर। ये बिल्कुल बिल्कुल नहीं है कि आप इसकी स्पेस कॉम्पिटेटिव टाइम कॉम्प्लेक्सिटी इसको चेंज करके ही बताएं और कि बात एग्जाम्पल को देखकर ही रॉन्ग आता है। नहीं, बिल्कुल नहीं, क्योंकि मैंने काफी सारे क्वेश्चंस किए हैं इसी तरह किए हैं। अगर मैंने उसको इम्प्लीमेंट, अगर आप लोग खुद करके चेक कर लीजिएगा कि एग्जाम्पल को हट के करके देख लीजिएगा, अगर एक्सेप्ट हो गया तो ठीक है, अगर नहीं होता तो ये देखिए कि आप वही पॉइंट्स देगा कि एग्जाम्पल्स पे, क्योंकि माइंड में गूगल में हमेशा ये दिया जाता है कि आपको एग्जाम्पल्स दे दी जाती हैं कि ये एग्जाम्पल है। अब आपको कोड करके देना है, आपको कोड के साथ टाइप करके देखना है ये एग्जाम्पल है। जैसे कि एग्जाम्पल में बताया था कि एक हमारे पास क्वेश्चन है, सही, और क्वेश्चन में ये बता दिया गया है कि हमें ये क्वेश्चन करना है। तो उसके बाद फिर हमें उसको उसका आंसर लिखते हैं। जी सर, स्टार्ट कर दीजिए।
Gee, the closing remarks for whatever the discussion has taken place, and I don't think we need this discussion once again. But Sarasa is absolutely right. Uh, just by just looking at the structure, you just read the problem, but this problem statement will not give you enough information to understand what kind of inputs are you actually expecting, right? So you can look at these base cases, consider these base cases for sure, and then of course, initially when we start to lead code, I told you guys need to look at the constraints as well. Without constraints, you cannot think about other use cases which might be worth considering, right? But these will give you a good start. However, in my experience, they may not be sufficient for. But yeah, I think that's the point. So read the question carefully and do not miss out on anything. If you get stuck, which kind of topic you can consider to solve the problem, you can look in the topics. Okay. All right. I think the two pointers algorithm we're talking about where you have sequences something like this. If you flip this around, if you again get the same pattern, then you find. So you can use a left and right pointer, where you can divide the length of that array and just move this pointer until the half length, and move this into the half length, right? And I guess you can also I don't know if you'll have to record a lot of things. Do one thing. Whoever has the solution, just post in the Slack. We'll try to move to the next question. I may not be able to explain to you the implementation for that, but at least I can share where I've been able to get so far, and then we can move from there. Okay. Okay. I hope this is clear to y'all. Where's the other problem? Maximum product subarray. Okay. I'll remove the code for now. So we were discussing this problem yesterday, maximum product subarray. So you need to find a subarray of this array that gives you maximum product, okay? And a subarray can be the single element itself, and a subarray can be combination of all these elements depending upon what you include as subarray. It can be 2, 3, -2. It can be 3, -2, and 4. It can be -2 and 4 itself, right? So the easiest and the most straightforward way to do this is you do brute force nested for loops, right? By nested for loops, I mean that you do an I and j, and then for each I, you keep multiplying all the j's and keep recording maximum by comparing the next maximum with the previous maximum and finally return the best maximum. And that's what we did with the buy and sell problem, right? Um, in fact, let's go ahead and implement that. At least we have that. It's going to be easier once you dive into the dynamic approach of that problem. Okay, so let me pull this up real quick. Okay. Let's try to implement this. So for each I want to move each j while comparing if the product that I've been able to achieve is the max product, right? So for that, if I say that my max product currently is 1, and if I want to loop over with an I do integer I is equal to 0. Integer I is equal to 0. Okay. While I is less than, the array is nums, so I'll do nums dot length, or we'll stick to the original pattern. I'm just trying to keep it as controlled as possible. Nums dot length -1 and I plus plus. This will go, this should go all the way to the end. So my I should go all the way to the second last. So that should be -2 instead. I want the second last index. And then for integer j equals 0, while j is less than or equal to nums dot length -1 j plus plus. Okay. All right. So for each I want to multiply all the other j's. In that case, I can do something like integer current product. If that is my current product, I can keep comparing the current product with the max product. Okay. So my I is moving until here. And for each I, let's say 2, 3, minus 2, 4. My I is here, and j goes here, here, and here. Multiplies all of this, okay? Now we're considering the entire subarray. On the next iteration, we move here, where we are multiplying 3, 2, and 4, and then we are multiplying negative 2 and 4. And then we can also compare if 4 is the maximum product or maximum subarray, but this is not a product, this is just a single element, right? So at each level, we can compute negative 8, negative 24, negative 48, negative 8, negative 24, negative 8, and 4. Are we missing out on something? Anyone? We're missing out because we have to check at each step what is the maximum product. We have to store the maximum product at each step. If you see here, we're getting 6. We cannot just multiply entire array and then start another loop. We have to check at every step, right? Yeah, someone was saying something?
अच्छा सर इसमें कुछ ऐड करूँ
जी
सर इधर में समझ स्टूडेंट को बता रहा हूँ कि इसके अंदर जो इम्पोर्टेंट नम्स है ना 2 और 3 माइनस 2 और 4 वो इसलिए कि हमें कैलकुलेट करना है किसी नंबर से कि हमारा नंबर जो है वो हमारा है प्लस में। तो हमारा जो प्लस में नंबर आ रहा है वो 2 3 से आ रहा है। अगर माइनस 2 और 4 से करते तो हमारा माइनस में आते तो फॉल्स कराता। तो इसलिए 2 3 को उसने किया। 2 3 से क्या आउटपुट हमें लेकर आना था 6। तो 2 3 हमें देखना था कि हमारा जो नंबर है वो किस पे हो रहा है कि जिससे 6 आए। तो 2 3 6 किया तो 2 3 6 होता है तो 6 आउटपुट है। अगर हम माइनस 2 को 4 करते तो हमारा माइनस में आंसर आता। तो इसीलिए इसमें एक्सप्रेशन में बताया कि 2 3 इज अ लार्जेस्ट बिगेस्ट लार्जेस्ट प्रोडक्ट 6। ठीक है। अगर एक्सप्रेशन नंबर 2 में देखें इनपुट में कि नम्स लिखा हुआ -2 0 -1 हमें इसको भी कैलकुलेट करना है। अभी देखिए कैलकुलेट करने से पहले ये चेक करें कि देखिए -2 और -1 लिखा है तो कैलकुलेट नहीं हो सकता क्योंकि दोनों तरफ माइनस आ रहे हैं। तो इसीलिए हमें प्लस का नंबर लेना है। तो प्लस का नंबर क्या होगा 0 मतलब 0 की कोई वैल्यू ही नहीं होती है। तो इसीलिए इसने आउटपुट क्या कहती है 0। तो लिखा हुआ क्या एक्सप्रेशन द रिजल्ट कैन नॉट बी 2 कोई भी 2 नहीं था। तो बिकॉज -2 और -1 इज नॉट अ सब एरर। जी सर पर
guys has a question.
Yeah, so regarding to subsequences, like we have this sequence. So here the 3 and 4 are also the subsequence or the subarray of this array. So why we can't multiply 3 with 4? That's give us a maximum product. But here we only multiply 2 and 3. And why we can't multiply -2? According to the second example, we can multiply 2 and 1 and that gave us +2. So what's the requirements of the question? I don't understand. Like if we are multiplying only subarrays, so here we
Sure.
have 3 multiply 4 give us the maximum product, but we can't do that. Why?
Because that's not a subarray. 3 multiplied by 4 is not a subarray. You're skipping the index upon which -2 has been stored. So if you look at this definition here, a subarray is a contiguous non-empty sequence of elements within an array. You cannot say that 3 and 4, if you multiply them or if you take two random indices from an array, that makes a subarray. You cannot just do it like this, right? You have to include -2 in here. Then only you can say that you actually cut out a smaller array from an array, a child array from an array, right?
Oh, so for the subarray, this is the requirement that that should be contiguous. Okay, am I right?
Not for just for this array, but whenever you see this keyword subarray, that will mean that you are considering contiguous memory spaces. You're considering taking indices, slicing indices from the original array, and you cannot modify the original array, right?
Oh,
You want to keep this as the standard. You cannot flip these elements around, right? All you have to do is just keep slicing it, but in a linear fashion where you're not disregarding or violating the rules of contiguous means one after another, right? So
Okay.
that's the
Thank you.
definition for it.
Thank you so
Yeah,
much. Thanks, sir.
no problem. Yeah. Okay. So we are multiplying all the elements. Okay. We are reducing the size of the array and we are taking product at every step, which means we have taken product for 2s, 3s, and 4s. Okay, and that's what we're going to do here. As you can see, I have introduced a current product. What I want to do, I want to compare this current product at every step when my J is moving forward, compare the current product with the max product, right? Whichever one is greater, that will get stored as the maximum product. And that's something I will do after I jump out of this J loop. Okay. Sorry, I can't do that. I have to include that inside this J loop. I have to calculate that here. Otherwise, I'll be getting the entire product and storing and comparing it. So let's take this current product, and multiply it with what? I have to multiply it with nums, which is my array, and wherever my J iterator is. So J is advancing with respect to I, right? And whenever J hits the end of the array, then J gets reset and I moves forward. And then that's how we continue until our I arrives here. Excuse me. When we're multiplying it, we also want to store it. So this operator will mean we're multiplying nums of J with current product and we're storing that value in current product as well. And this will be similar to, for those who don't know, this will be similar to if I would write something like this and set it to current product. The same thing. You're taking the current value, multiplying with the new nums value and storing it as the current product's new value. Okay. Now is the time for me to compare my current product, whatever I find now, with the max product. So the max product known is 1, right? And now I need to compare these two. And we'll keep doing that at every iteration. Okay. And then we'll keep updating the current product. So I can say I want to know my max product. What is my max product going to be? It will be a result of this equation right here. We'll use an inbuilt Java function, math.max, that takes two values, compares and returns the largest of the two values, okay, or larger of the two values. So you can put it the other way around as well. You can put current product at first, and the first placeholder and the max product on the second. So now we'll just take this current product. Okay, and once all of our iterations are done, finally we'll have recorded max product. Now this max product will not update in one condition if the current product, the new product that we evaluated, is less than the max product. So this function will make sure we're recording the correct value. And now finally we can return our max product. Okay. So let's see. This. Okay, one case passed and another case failed. Most likely it's due to this one right here. The max product should be a value that determines how much an integer can take. Let's see. Maybe that's not the reason why. Or we can, let's see if this works. Okay, non-initialized needs to be initialized. Integer to max value. Here to min value. The integer to min value. Let's see if this works. Integer to min value is used. How much is this? How small number can be that this can store? And the algorithm should be fine, I think. Okay, well, we're not considering cases where we have this. At the same time, it's returning this issue. Oh, we'll have to. Can someone suggest something? What if we don't have anything? What if we have only single element? In that case, we should just return the first index. That could work. If you have only one element. Still same issue. Maybe it's returning 0 because it's not going to the end. So in case of these, of course, I have to return this. Current product is equal to 1. My I goes all the way to the end. Y plus plus. Current product equal to 1. No. I made a mistake here. Like I said, my I should start next to J, right? But since we're taking a product, we have to include that as well. Oh, let's try this. Okay. What if we do something like if I is less than or equal to num_sort length, and we do I want to go to -2 and this to -1. Does that still give us the same? What's going on here? It's less than or equal to num_sort length. Expected comma. Why? Num start length -1. Guys, please be proactive in the sessions. Don't just sit and watch things. Correct me, suggest things. It's okay if you get it wrong. I think this is the problem.
I think we need round brackets after length function before -1.
But why is this not giving an issue here? Okay. I think that works better. Less than equal to is not working for some reason. Anyways, I'm not gonna waste more time on this. This is brute force of n square, I and j. For each I, you're running j, so you have O of n squared time complexity. Okay. Now you need to reduce it down to O of n. And I have a working solution for this. I'll just discuss because we have not much time left. I'll try to discuss my approach, and hopefully you guys will be able to get it. It's a recursive approach, more of a dynamic programming problem, dynamic programming kind of approach. In dynamic programming, what we do is we use recursion, and but in an optimal way. What is recursion? A recursion is basically a function calling itself until it meets a base case, right? If any of you have ever solved Fibonacci sequence problem, you might have come across recursion. But what recursion does is it defines a base case, okay? For example, if x is equal to 0, while x is not equal to 0, it keeps calling the function and keeps executing the logic itself until you meet this base case. So for example, if you want to subtract this, you initially the value you've been given is x is equal to 5, okay? So you want, instead of writing loops, you use the same function and you tell the function, keep subtracting x minus 1 until x is equal to 0. So the function will call itself. Inside the function, you already have this operation. This will get called. And once you reach this, then it will return the function. And let me give you a much more try to give you a much more clear explanation. So recursion would be something like, you have a function, right? Subtract x, and you have been given an input. Okay, and input is x, which is integer x. If x is equal to 0, then in that case, what you do is you return. Okay? If not, you keep calling this function, which is the subtract x. Inside subtract x, you need to add another logic, which is x minus 1. So every time you're again calling the function, you're subtracting 1 from x. So now if the value of x was 5 before, now that you're calling this function again, you're calling the function with 4. Okay? You keep calling this function until you hit this base case. Now that you have hit this base case, now you start returning from the function. So now, once you start returning, you can put a string or a print statement here, right? X is 0. You keep returning this, and finally you get this answer from where you started calling it. And we can discuss this recursion later. But for those who already know this, my approach for this problem in terms of recursion was is that two things I need to keep in mind. First is if we have a 0 in that array, let's say 1, 2, 0, 2, 1. If we have a 0 in the middle, I will just compute the maximum product for this and this, because if I multiply 0 with any of those, if I create a subarray with 1 to 0 or 0 to 1, or even including the entire subarray, then it's going to return 0. So this will not be your maximum product. The maximum product you can get is 2. And then again, you can get a product from this. You'll have 2 here, and you'll have 2 here. You can compare. These both are same. That's again your maximum product, right? Or let's say if you have a number here, like 4, you're getting 4 here, you return 4. Okay, so that is what you're going to use recursion for, is that first thing you need to keep in mind is you need to break this array down into smaller subarrays. Okay, every time you have found a maximum using a for loop in this array, you break this array down into 2, 3, -2 using recursion, right? You call the function reduce the array just like I was reducing x, and then you run the loop again. Another case, if you have even number of negative numbers, don't worry, just multiply that as is and just keep reducing the array. If you have odd numbers, let's say you have 3, then you can split the array just like you did with 0. You can split the array around this odd negative number and then compute subarrays. And by using recursion and for loops, finally you'll arrive at the maximum product. I'll share that solution with you in the Slack. Go through it. If you don't understand it, that's fine. I haven't fully been able to understand the code. But yeah, we can explain that on Monday or the next day of the session. But let me get that solution for you guys. Sarasa, did you understand that, my approach? I think I've shared that solution with you as well.
सर असद का नेट इशू था जिसकी वजह से वो लीक कर चुके हैं।
अच्छा अच्छा, ठीक है, कोई नहीं। सेशन 2 मिनट में ख़त्म हो जाएगा। एनीवेज, इसका एक ऑप्टिमल काडेंस एल्गोरिथम है जिससे बड़ी इजीली सॉल्व हो जाता है डायनामिक प्रोग्रामिंग का, लेकिन मैंने इसको ब्रेक डाउन किया फॉर लूप और रिकर्जन में, ठीक है? और आई रियली लाइक you guys to actually, if anyone can understand this before the code before me, that'll be great. But that is also the same time complexity that the dynamic programming will give you. So use recursion and for loop to break the problem down in subarrays based upon zeros and negative numbers. And finally, you have your maximum product by using the same math.max. So, okay, that's all from my side. Sorry I couldn't conduct this entire solution. I'm also a little bit tired. But inshallah, next time we'll do better. Jazakallah khair.
ओके सर, थैंक यू सो मच। हमारे जो सेशंस का टाइम है वो खत्म हो चुका है। किसी का कोई क्वेश्चन है काइंडली वो सर से पूछ लें।
Okay, I guess we're good. Allah Hafiz, everyone.
अल्लाह हाफिज।
No.